Good morning, students. In this video, we are going to discuss the case study on multiplication of positive numbers. Before we are proceeding with the case study about this particular topic, already we have covered about what is this multiplication of positive numbers through the regular class. In this class, your classmates is going to deliberate this particular topic through the case study. How this multiplication is working.
My name is Varshan. About this topic in computer organization architecture, multiplication of numbers.
Multiplication of positive numbers.
Multiplication of positive numbers is used to, unlike addition and multiplication operations, is a iterative algorithm. Unlike addition multiplication operations, the repeated algorithm is adding and shifting. The common method is shift and add algorithm shift and add method. Given two numbers, multiplier q, multiplicand m.
In this method, we shift and add multiplier. We consider as m as a multiplicand and q as a multiplier. We using multiplier to multiply the multiplicand. For regular method, pencil and paper method, we use 12 into 3 like this method. But in this multiplication of positive numbers, we are taking.
While we are going with the normal multiplication method, we will have a two components, right? One will be the multiplicand and another one will be the multiplier, right? That is m and q. If we are giving this multiplicand and multiplier, the multiplier stating that this much time we are going to do the addition of this multiplicand. That only it is performed here. Instead of multiplication, here we are performing the addition, that's all. Okay, 12 plus 12 plus 12. 3 times we have used the 12. Here 12 is the multiplicand and the 3 times is the multiplier. So after adding this 12 3 times, we will get the value 36. Okay. The same thing how we are going to perform in the system, computer, that we will explain.
In computer science and organization architecture, we consider the multiplicand and multiplier as binary numbers, and we multiply the multiplicand using multiplier. Then we get the partial product. The answer will be, we are multiplying the multiplicand using multiplier. For multiplying with 1, the value will be the same of the multiplicand, the same double times, and we are multiply with 0, we get 0, and next we multiply with 1, we get the same value. After the multiplication, we get 8-bit product, because we consider as 4 multiplicand and 4 multiplier. So 4 plus 4, 8, we are getting 8 bits of product. We check using binary value. We check this is the correct answer using multiplier values. We get the final value. We check using this method. So we get 8-bit of product.
This method is a paper we do in paper or pen method. But this I am going to say about the what is doing in computer inside the computer. We take it as a same multiplier and m and q. We using the a as a register and taking carry. See if there is any in multiplier or multiplicand have 3 bytes, we change into 4 bytes, 4 bits. So we want to check, we want to take the multiplier as same number, and we want to, this number is taken by
Initially, the A value, A register, it will hold the value 0. Okay. Then the carry bit also it will be 0. Based on this Q naught value, we will perform add and shift. Either we will perform add and shift or just we will perform shift alone.
We take it is a initial configuration of n bits. By using the n bits, it is a initial configuration, and it is a q naught. Q naught value is a starting of 1. If the q is equal to 1, we want to add and shift. So we add a and m. A and m. After adding 1101 is a value. Here is we want to store as a value here, and q. If the number q is equal to 1, we want to add. We add and shift. We want to shift the number into next value. So we shift 1, this one 0, 1, 1, last 0. Here is an if we shift, he takes 0, and there is nothing number in carries. So here is a 0. Next, we want to check the last number. It is a q 1 or not. If it is 1, we want to add and shift. So here is 1. So we want to add a and q, a and m. We taking 0, 1, 1, 0.
The first cycle A value is 0, 1, 1, 0. The same value considered here. Then the multiplicand as such 1, 1, 0, 1. We have to use this two value to perform the addition.
After addition, there is a 0, 0, 0, 1. We take this update A in this position, and we get carry. So we place the carries in carry position, and we want to check the last position is a 0 or 1. Next shift.
After performing addition, what operation we have to do? Shift. Now we can.
We shifting the 1, 0, 1, 1. It is a carry value shifted, and there is no value is we taking it as 0. Next cycle is we want to check the last number is a 0 or not. It is a 0. Q naught is ended with 0. So we want no add or no. We don't add, only shift.
No need to perform the addition operation. Just we have to make the shift alone.
So we shifting is value is getting, and there is no carry value, so we can take 0. After we want to check the q naught is equal to 1 or not. The value is 1, so we want to add a and m. The a value here is 0, 1, 0, 0. So 0, 0, 0, 1, 0, 0, and m value is 1, 1, 0, 1. So after adding, we get carry and a. We want to replace this a, update a, and take the same value as q. We get carry, so we place the carry in carry position, 1 in carry position. If after adding, we want to shift, so we shifting the number. There is no carry, so we take 0. The last 8 digit will be byte will be the product. The same method is here checking is applied to this to check the value is correct or not.
Zero you can ignore. First you can write 128. Last one. For last one you can write 128.
So after adding the
This value
1 we get
Add all these value, you will get
143.
143. Okay.
thing.
The case study illustrates how binary multiplication of positive numbers works on COO using shift and add method. In modern CPUs uses latest technique like Booth algorithm and array multipliers. The process of fundamental forms a foundation of multiplication hardware design. Thank you.